So, I'm going to teach you how to derive the formula for circumference using the arc length formula that I showed you in my previous video. So, or circumference of a circle to be more specific. So, let's make a little picture to help. Let's try find the circumference of a circle with a radius r centered at the origin. Now the formula for this circle is x squared plus y squared equals r squared. And we could implicitly differentiate this, but it would be kind of a pain. So let's solve for y. So y equals the square root of r squared minus x squared, right? Move x squared to both sides, take the square root. So this is simple. This is easy to do. We can do this. So we want to find the arc length, which would be the arc length of our circle function, which would be which would actually be our hemicircumference, the circumference of half of our circle. So we're going to take the integral of our, where this is our function, of the square root of 1 plus dy dx squared dx, and our limits of integration, well, what are they going to be? They're going to be the limits of our curve. So we want to find the length of our curve from here, from one side of our hemicircumference to the other side. So if this is radius r, that means this length is negative r, and this point is r. So we're going to integrate from negative r to r, right? So dy dx, well, what's that? Well, you know that y equals r squared minus x squared to the 1/2, right? Because raised to the 1/2 is the same as the square root. So let's take the derivative of both sides. So derivative of y with respect to x, well, it's derivative of y with respect to x equals, okay, this is a function, our x squared function within our square root function, so we're going to have to use chain rule. So derivative of our inside, which is negative 2x, times the derivative of our outside. Well, take our exponent, drop it down, and we'll have our original function r squared minus x squared raised to the 1 less than our exponent, which is negative 1/2. So let's simplify this. Well, 1/2 times negative 2x, that's negative x. And instead of saying r squared minus x squared to the negative 1/2, let's just say that's the square root of r squared minus x squared, all under our negative x. So we know that this equals dy dx. So we're going to plug our dy dx into our original arc length function. Excuse me. So we're going to take the integral from negative r to r of the square root of 1 plus dy dx, well, that's negative x over square root of r squared minus x squared, all that squared, dx. So, well, we can simplify that. The integral from negative r to r of the square root of 1 plus negative x squared, that's x squared, over r square root of r squared minus x squared, well, that's just r squared minus x squared, right? Dx. And now, well, let's give these common denominators. So we'll have the integral from negative r to r to the square root. Let's call this one r squared minus x squared over r squared minus x squared. and this will be plus x squared over r squared minus x squared dx. So we have the integral from negative r to r to the square root of, well, r squared minus x squared plus x squared, that's just r squared, over r squared minus x squared, all with respect to x. So if we have a quotient within a radical, we can split up the radical. So we'll have the integral from negative r to r of the square root of r squared, well, that's just r, over the square root of r squared minus x squared dx. And let's take our r radius, well, that's just a constant, so let's take it out of our integrand and make it the r times the integral from negative r to r of dx over the square root r squared minus x squared. Wait a minute, we know exactly that, because that looks exactly like because this is the derivative of arcsine. So the integral of this must be arcsine. So we're going to have r times arcsine of x over r taken from negative r to r. Get another piece of paper here. I never said it was going to be a short proof. So we have this. So let's plug in r and take that from the difference of r plugging in negative r. So r times arcsine of r over r minus arcsine of negative r over r. So that'll be the same thing as r times arcsine of 1 minus arcsine of negative 1, right? And we know that the arcsine of 1 and the arcsine of negative 1, we know what those are. So we'll have r times the arcsine of negative 1, well, that's pi over 2, right? Because the sine of pi over 2 is 1, minus the arcsine of negative 1, well, that's negative pi over 2, right? So r times pi minus pi over 2, well, that's pi. Okay? Wait a minute, isn't the formula for circumference 2 pi over r? What happened? Remember, this formula that we used to get our dy dx, that's for just this top half. That's just for the positive hemisphere of this circle, the positive hemicircumference. So to get the whole circumference of the circle, we have to multiply it by 2. So we have to multiply this thing by 2. So we'll get 2 pi r, which is circumference. So now, whenever a math book tells you the circumference of a circle is 2 pi r, you don't have to just take their word for it. You know that it's true.